When we're using the chain rule, we're going to be talking about having something, so in this case a little baby, inside something else. So the analogy is kind of this baby thing inside something else. So inside this pregnant mum. So baby inside mum. So there'll always be kind of baby function and then the mum function. And this is kind of a way of thinking, well, what's the mum bit and what's the baby bit? And then we can use the formula. So an example of something inside something else is this. This is the bit inside, the 4x plus 1, and the bit outside, the function outside, the mum is saying cube it. So we want to work out how we can differentiate this without having to expand it first. So the formula we can use is that dy by dx is d, now we're going to have the mum, so I'll do another little drawing, d mum with the baby in. Now that's important. So we're differentiating with respect to x, but the baby is still inside. Not a very good drawing. And then what we're multiplying that by is just the baby. Differentiated. So dy by dx is the mum function differentiated with the baby still inside. And then we multiply that by what we'd get if we differentiated that baby with respect to x. So let's see what it means for this example. So we want to find dy by dx, and we know that this is y. So first thing, we want to differentiate the mum function, so the cubed. So what we do when we do that is the 3 will come down to the front, and then whatever's in the brackets will now just be squared. So we're effectively differentiating x cubed. And then the baby bit is going to stay exactly as it was, like that. Now we need to multiply by what we would get if we differentiated the baby. So what do we get if we differentiate this middle bit? Well, 4x differentiates to 4 and 1 differentiates to 0, so we're just left with this. So then tidying up, we've got 3 times this times 4, so we've got 12 times 4x plus 1 squared. Here's another example. So let's try and identify which bits are the mum and which bits are the baby. So the baby is always going to be the bit inside. So the bit inside for us is the bit in the brackets. So the baby is 1 minus x squared. And that means the mum must be 3 and then whatever it is to the power of 6. So what we're going to do to differentiate, we get dy by dx. What do we get if we differentiate the mum's function? So that 3 is going to stay at the front, isn't it? Because it's a constant, so we don't worry about that. Now this 6 is going to come down to the front too, because it's a power, so we multiply by 6. And now whatever in the brackets will be to the power of 5. We take 1 off the power. And what's in the brackets stays the same. That is the baby. 1 minus x squared. Right, now I've done the mum's bit. Now we just need to multiply it by what we'd get if we differentiated the bit inside, the baby function. If we differentiate 1, we get 0. If we differentiate minus x squared, we get minus 2x. So now our final answer is, well, 18 times minus 2, so minus 36 times 1 minus x squared, all to the power of 5. Oh, missed an x. So there, that's from that. To see that this function is something inside something else, we'll use the fact that we know that reciprocals can be rewritten like this. So now let's identify the baby, which is the bit inside, and then the mum is just saying, okay, well, whatever this is, raise it to the power of minus 1. So basically the reciprocal. So the mum is the reciprocal function and the baby's that bit inside. So now we want to differentiate dy by dx. So what do we get if we differentiate the mum? Well, that minus 1 is going to come to the front. And then we've got whatever's in the brackets and now we take 1 off the power, so it'll be minus 2, and then we can put the baby exactly as it is in the brackets, 3x squared plus 4. Now we just need to multiply this by whatever we get if we differentiate the baby function, which is this. So if we differentiate 3x squared, we get 6x, and if we differentiate 4, we get 0, so it's just multiplied by 6x, and so that gives us minus 6x over 3x squared plus 4 squared. Okay, here's another thing where we've got something inside something else. This time the baby is going to be this bit inside the brackets because it's inside the sign. And then the mum is the sine function. So we know what we get when we differentiate sine. We know that that goes to cosine. So we've got cosine and then whatever is in the brackets, the baby bit, and then, well, we can put that in, that's 4, well, I'll do it in red so remember it's the baby, so 4x plus 10. And then we just multiply by the baby bit differentiated, which is, if you differentiate 4x, you get 4, and if you differentiate 10 you get 0. So altogether we've got 4 cos 4x plus 10. Now we're at a stage in the video where I think you'll be able to have a good go at these on your own, so pause the video, have a go, and then watch how you do it, and do this definitely for the next few if you haven't been already. So now we want to see which is the baby. This is the baby. What's the mum function? The mum function is cosine function. So dy by dx is, if we differentiate the mum function, which is cosine, we get minus sine. And then we leave the baby in the brackets, so x squared plus 1. Now we multiply this by what we get if we differentiate the baby. If we differentiate the baby, x squared differentiates to 2x and 1 differentiates to 0. So altogether we are left with minus 2x sine x squared plus 1. Pause the video. Okay, so this is the baby inside the brackets, the mum function is sine, and we differentiate, and if we differentiate sine we get cosine, the baby bit stays the same, cosine of x squared, and then we're multiplying by what we get if we differentiate the baby, which is 2x. So altogether we have 2x cos x squared. So important distinction between this one and the last one, and it's going to be more helpful for us if we remember that sine squared x means sine x squared. So now we can see that the baby is the sine x and the mum is squaring whatever's in the brackets. So if we differentiate x squared, then we get 2x, so now we're going to get 2 of the baby, and the baby's sine x. And what do we get if we differentiate the baby function? Well, we get cosine of x. So we get altogether 2 sine x cos x, which you may recognise as sine 2x. Now, if we want to formalise this, we can look back at our first example, and we can see that what we're actually doing is we've got one function of another function. So the bit in the brackets is our baby. So we could say that g of x is 4x plus 1. And then the f of x, what that function's doing is cubing it. So f of x is the function x cubed. Now, what the chain rule gives us is that dy by dx equals, well, we've got differentiated mum with baby inside, so that's f dashed of g of x, because that f dashed means that it's been differentiated, and that g of x means that it's still the same inside. And then multiplied by g dashed of x. So that's the formal way of writing it.